Hello, everyone. I'm here with Kinneret from a really innovative company called GeneNeer. Now, Kinneret, thank you so much for coming on. I would love to hear about your company and your background a little bit. Let's start with your background. W- tell me your specialty and how you started this company.
Well, let's start by thanking you for having me.
Of course.
And I'll quickly introduce myself. My name is Dr. Kinneret Shefer. My background is that I did my PhD at the Hebrew University at Givat Ram at the genetic department. I investigated the RNA structure, the core of telomerase RNA structure, and then I continued to postdoc studies at UC California, UCAC, at the RNA Center. So basically, I'm an expert in RNA structure and functions. And when I came back, I felt like I did some more research at the Weizmann and kept on, publishing journals, but I wanted to do something different. I wanted to use my knowledge to actually have some application to it. And I started the company. I registered the company in 2016, raised some money from the innovation department, NUFA, if you know, it's a very small amount of money, and established a small POC with the help of friends that just gave me a space to work at. Submitted a provisional, and that's how I started. But only somewhere later on, I decided I want to have a partner. So I looked for a figure that will be that has the potential to contribute significantly to the company, and I asked Professor Shosayov if he's interested in the technology, and he was interested in it, and he joined me on my cruise, and the first fund that we raised, the first real fund, was late December 2019. So basically, the company really exists when it gets money,
Yeah.
which is about almost 220, so almost 3 years. We have Nitzan Lugassi, Dr. Nitzan Lugassi, as our R&D manager. Very talented researcher that holds a PhD from the Beersheba University and postdoc from the Vulcani Center, and he's an expert in plant physiology and especially in drought and other abiotic stress effects on plants. And we have a small R&D team, and so lately, the last year, we started to interact with the market, and maybe I should tell you what the technology is about.
Yeah, please. I'm so curious.
Okay, so the technology is basically very simple. All it does, it locks traits and open them on demand. Basically, we develop locks, genetic locks that doesn't go to anything, so they don't add any new protein to the cell. They're based on RNA structure, and we target them to a specific gene that, when expressed, it's responsible to the expression of a trait. So this gene is locked, and when there is a need to unlock this gene, we introduce an inducer from the outside of the plant by air spray, just spraying the plant. This inducer is a chemical that penetrates the cell, change the structure, and now allow the expression of this gene. And now you might ask yourself, why do we need such a thing, right? Why do we need such a switch, something that switch off and on? So at the high level, think about that today you can introduce new gene to the genome, but then you don't control it. It's like having the electricity all the time on. It wastes energy, okay? And it affects the plant physiology in so many ways. And especially when it's come to abiotic stress genes, by definition, they are stressed genes, and they put a lot of havoc on the plant physiology, and you don't want them on all the time. So in many aspects, our technology is just the next dimension that add a new dimension, which is time for traits, okay? And give the grower a tool to active specific traits. So let's take, for example, drought tolerance, which is one of the applications we work on. We work on two main applications. Drought tolerance is, many companies tried to generate drought tolerance crops. But as I said, by definition, those genes are stressful for the plants. And therefore, if you don't control the activation, they disrupt the yield, they reduce the yield of the plant. And therefore, at the end of the day, you might end up with a plant that is more tolerant to drought, but it's small. So that's not something that you want as a grower. And what our technology add is some kind of a shield. The growers has the potential for drought tolerance within the seed. He gets the seed with the potential, but the potential is locked. So under normal growth condition, the plant can grow normally. It will not be affected by the stress gene. But if an event of drought is about to occur, and prediction is very accurate today, the growers has a tool to activate the defense system for a limited time. So if we compare it to, I don't know who are the listeners, but if they are Israeli, so it's like the Iron Dome. You don't want it to be active all the time because it wastes energy. You want it to be active only when you need it, and then you want to be able to shut it down. And that's what we do. So we give a protection, but only when needed. So one of our applications is drought tolerance, and we aim, and our vision is to increase food security using our technology. So our technology is a platform. We can direct it into many, many applications, but we are focusing very much on the aspect of increasing food security and touching the most essential problems in the agtech world today. So one of them is known as the drought tolerance, that there aren't currently any great success generating such a drought tolerance plant. The second application that we are applying is controlling and enhancing and improving the gene editing process. So you probably know that today you can enhance crops by simply making small changes in the genome using gene editing. So there is this machinery that you might heard of, which is the CRISPR-Cas, right? Probably everybody heard about it. You put this machinery, you introduce it into the genome, and this is a gene that codes to a protein called Cas9. This protein with a guide knows where to go to a specific, very specific gene and make small changes. And those small changes enhance the crops. Enhance as for more tolerance to drought or more nutrition, and all kinds of elements, more resilience to pests or to viruses. So using gene editing, there is a whole world that we can improve and enhance different crops. We are very excited. We are very excited because in my vision as the CEO, I want to have, like, in less than 2 years, running systems in potatoes, sweet potatoes, tomatoes, that can give and answer the market fast, very, very fast, to the market needs. If there is a new virus, it's us that can make it fast and make it resistant. If there is a new problem, if there is a new need, if there is, we are I want to have those platforms running and addressing different elements in a very accurate, low cost, and the most important part is fast, because in the ag tech, the biggest problem is time. And from the time you start working on something until you get something in the market, it can be 10 years. And I'll give you a secret. I'm a molecular biology. I have an expert in plant, but I immediately noticed I was really upset. Everything takes forever. And I told my R&D, now our mission is to make it fast, because I don't like it. I don't like it that it takes forever. And everything that we do now, the main parameter we have in mind is how to make it fast. So that's, but that's not on the expense of quality. So we are very excited and hope to spearhead the entire field of enhanced crop. And I think that's interesting, right?
Wow, that's
Thank you.
amazing. I never, okay, first of all, tell me, okay, I'm trying to understand the drought. It's like basically drought prevention. So basically a lot of crops, there's not enough water, right, in the world. So what you're doing is you're making the crops, you're making the crops resistant to drought, but if there is no drought, then it's either you could turn it on or off. So it doesn't have to be resistant unless it needs
Exactly.
to be. Because if it's
Exactly. I will
resistant,
give you, I will give you an example.
please,
Okay.
yeah.
There is, so you can ask yourself, some of the drought tolerant genes are even with are embedded within the plants, some of them. But the plant did not evolve fast enough to adjust to the rapid climate changes. Today, what's going on outside, the plant, it just did not evolve. So every time you hear drought event, basically means 20% lost in yield in that area. It's a major thing, okay? So I want to give you an example. A gene that called LOS5. It's a wonderful gene. It closed the stomatas, the little holes on the leaves, it closed them. And by doing that, it increased the yield during drought, but during drought only, by 20%. But it also prevent CO2 flow into the plants. Therefore, that disrupt photosynthesis and cause the plant to be smaller. So yes, you have 20% more survival, but the plants are small. That's not what you want as a grower. So imagine that the growers sit at home and can hear, oh, in 24 hours, you're gonna have an event that cause you to lose 20% of your crops. And they say, oh, really? He goes out, spray our inducer, protect the field, and prevent the loss of the crops and also the frustration, because now he has something in the hand that he can actually do. And that will active the defense system for a limited time. So after a while, it can go back to normal. The plant can go, the stomata can open again, okay, and it can go back to normal. And if there is another event, it can do it again. So what we are actually selling is two things. First, the seed with a protected system, and which is the locked, we sell the lock within, and also the keys, the inducer that you can spray either by air spray or by tractor spray, which are tools that growers use all the time for other applications. So he doesn't need to learn anything new. The only thing that he has to know that he has a tool to now do some. He has to be active, yes, but the growers are also active when they want to protect against pests or herbicide. So they know how to take an action when it's required. It's not a new notion that we're bringing to the growers. The only new notion that we bring in is now you have a tool to be protected against extreme weather events.
Wow, that's amazing. There's no reason why any farmer wouldn't want that. I
Yeah.
mean, it's not like there's any downside to the actual crops unless you spray what is it? It's a solution. What do you give them to spray? Just like it's a formula you guys created that activates the shield, and that's it.
Yes, and it's quite cheap.
Really?
It's quite cheap. It's not toxic. You can find it in other industries such as the cosmetic industry, etc. So we do not expect it to be any effect on the land or the crops. And yeah, it's a tool. and we are
That's
working on this. So those are the two applications. Both are aimed very clearly to uh, to solve major problems in the ag, and we can do that because we add something new, a new dimension for that is not present today. So, but we do have competitions. If you want to talk about the competitions, there are other companies such as Pairwise and Inari that also works on improving the gene editing process. I don't know exactly. They don't have our technology. We have IP protected, very unique technology. So, but they might have other technologies, not necessarily doing what we are doing, not necessarily as fast as we are doing, but we are not the only one. And I can tell you that each one of them already reached to the value. I think they're more than zero point 0.5 billion dollars. So they are richer than us, but they still need to have their product in the market. And since we are quite fast, and if I may say, excellent R&D, small but sharp, I have a strong feeling that we have potential to be something major in the field of AgTech.
listen, I see your vision. I see it. It's, I mean, you know what you want to do. You created it, and now you just got to put it. You just got to use it. I don't know what's ready. I don't know what's exact. Is let's say the drought protection. Is that ready? Can you put that in
I can
crops
tell
today?
you what we have for sure. We have a POC showing that we established it for first POC was for the investors, something that you can really visualize and see. So we can present it and it's very easy to understand. So we have our POC showing that we can control plant traits, and we chose two traits, herbicide tolerance and plant size. So plant size, you can easily see that we control a gene that's related to plant, and you can see that when we activate, it's 3 times bigger. It's very easy to see. We even have a movie showing, how it grows. We spray with the inducer, unlocking, and it goes up. It's really cool. And the other one is herbicide tolerance. Um, we show that that when we do not open the herbicide tolerant genes and introduce herbicides, the plants dies. But when we open them, they're alive. And now, right now, as we speak, the drought tolerance assay is running. I assume that we will gonna have first results, I guess, in 6 months, something like this. And we also establishing right now the basic for the gene editing fast platform in potatoes. We already establishing the platform to work on potatoes and sweet potatoes. And altogether, we believe that our first product, and that's very much depends on, also funding, because more we have, faster we can go, put more crop. I mean, there is always the limitation of the crop itself, but pay attention, we chose potatoes, which are quite fast to grow. Okay, we chose something that we can see, we can get to a product quite fast. So we think that we're gonna have our first product ready in 2.5 to 3 years, and that's fast in the ag work. Okay, that's fast. Taking under consideration that we'll need to establish the platform, and I can tell you that once the platform will be ready, the next enhanced crop will take 1.5 years, not 3 years. So basically, the challenge is to put the platform, but once you have it, you can introduce many editing application into it. It's gonna run. And so that's the vision. The vision is
Everything takes time. It's not that much time, but everything takes time. I mean, obviously, you tested it and it works to like a good enough degree that you're working on making it full scale for the for the whole world. I mean, you can use this. You'll be able to use this anywhere in the world. I'm assuming there won't be anywhere.
Right? Our business model, basically, if you're asking about the word, how are we going to interact with it in space? For me, as the CEO, you're asking me how we're gonna uh, introduce it to the world if you're talking about the word. So it's a hybrid model. We are not, we don't have any intent to work on the big crops such as soy and corn because they are have unique strains that hold by the biggest company, and there's no way they're going to let us in.
Yeah.
Okay, so basically, if the big companies, the tier one companies, will want to apply our technology to their crops, we will sell licensing and cut a share from the royalties. But then we're talking about income from licensing and maintenance free, milestone freeze fee, but the big money comes from actually getting part of the royalties. At the same time, we are eager to have our own product and sell it still B2B. We are
Hmm.
not going to grow, make big farms, but we're going to produce. We're going to produce enhanced crop and sell it to the for example, we can sell enhanced potatoes for PepsiCo, and they're gonna distribute it to all the growers, and then we can get a share from the sales. Um, not of the we're gonna get the share from PepsiCo, not from the growers. So it very much depends who are we interacting when it comes to product. Uh, it's we might, you can call it licensing, selling a licensing to use the product, or sometimes a company wants to be the only owner of the product. So that's a different kind of contract. So, but that's the business
Yeah.
aspect. It's hybrid, both on licensing the technology itself for the big companies and selling the right to use. You can call it licensing of the products.
Well, I mean that makes sense. Go for every market if you can. I mean,
Of
people are
course,
gonna. I think people are gonna want it if it definitely if. I mean, it works. So people are gonna want. Which farmer wouldn't want that ability? I mean, that's they're
yes.
they're they're up
Yeah,
at night, like having nightmares of like situations where their crop doesn't produce because of drought or whatever, and you're giving them a solution.
right.
So
Yeah,
no,
there are
not just
very
that. You're saving a lot of crop. I mean, you always hear all over the world. You always hear there's different weather scenarios that destroy crops or make the yield a lot less, and it's very scary. And then prices go up. People can't afford to buy certain stuff, and it's just a mess. So this is a real this is a big deal. This is a big deal.
I didn't even start talking about, the situation of the global warming and the food supply and chain and how fast it is, because everybody knows. The
Yeah,
only thing I can say, I don't think I need to elaborate about it. I mean, you go to the market and you know what
yeah,
you can buy less today than
yeah,
you did like 6 months ago. Okay. I'm not talking about years ago. I'm talking about a few months ago, you could buy less for the same amount of money. So I don't think I even need to elaborate, but I can tell you one thing. There was a German VC to be ahead, a wonderful VC that invested in us about a year ago, maybe less, as they invest in technologies that has the potential to affect the future. And about a year ago, it was the future 10 years from now. No, we're not talking about 10 years from now. It is now.
yeah,
And that's why I came with this, oh, to my R&D, we don't have time. Just move fast. Just move fast. And I really see, I really want to be part of the solution. It's not just for me. It's not, yeah, money is nice, and I know that my investors need to be
yeah,
uh, want to get what they
yeah,
they deserve, because they took a company from a small company and make it possible. They deserve it. And everybody that works hard in this company deserve to also profit from it. But for me as a person, yes, I like it to be profitable, but I also want to be a major solution to make a difference. For me, it's important, and I think that many times it goes hands by hands, because when you make something major, it's also worth money.
yeah, yeah. Wow. I mean, I'm blown away, and I'm also very excited to see what the future holds for GeneNeer and to see where it goes because, as you said, the timeline is not that long, and the products are mind blowing. I mean, this stuff is incredible. Just just the fact that you can take genes and work on them, that's amazing. But to actually put them into crops and save crops or make them better, that's next generation. So it's I mean, just me, a regular person hearing this stuff is, is always it's just very exciting. So I mean,
It
yeah.
is. It is, and I think that what happens when you combine different elements, such as hardcore molecular biology with hardcore plant person, and business developing, and when you combine a line of a team that can lead such a project and has the creativity and the passion to make it, it's then I think that's the power that makes it work.
Yeah. Well, Kinneret, thank you so much for joining us. Thank you so much for telling us about your amazing company, and I can't wait to be in touch and to hear what you guys are doing in the future when your products when it comes out and people and crop they're using it in crops everywhere. I cannot wait to see that. But really, thank you for your time, and it's been super interesting.
Thank you.
Thank you.